Hi guys, today I'm going to talk about the physics behind my hopper. So in here, we have a rubber band. You twist this to get tension in there and get this back part to move back and forth. We start off with Hooke's law to find the spring constant. Hooke's law states that the force is equal to the constant times the displacement. Here we have a chart with mass, force, and displacement. So I actually knew these masses. To find the force and displacement, I had to run an experiment. So this is the experiment I set up. I tied a mass to a rubber band and measured this displacement. Since we have two lengths, I multiplied it by 2. I did that 4 different times with 4 different masses. Using these values from the chart, we construct a graph with force in the y-axis and displacement in the x-axis. And the line and the slope of the line gives me the average spring constant of 9.68 newtons per meter. We move on to angular velocity. Angular velocity is equal to the rotational distance over time. The rotational distance is actually 120 degrees. That's this distance from one side to the other. Now, I had to find the number of rotations in a given number of time. So using the video I showed you guys, I counted the rotations and the time. That gave me 12.47 radians per second. With the angular velocity, we can use rotational kinematics to find the angular acceleration, which is alpha here. So one of the equations states that the final angular velocity is equal to the initial angular velocity plus the angular acceleration times time. So we have all these values, assuming that the initial angular velocity is 0, except for the angular acceleration. Now, solving for angular acceleration, we find that to be 7.42 radians per second. Looking at the free body diagram here, we have two forces acting on my hopper. We have the force of drag and the force of repulsion. We can calculate the force of propulsion since it's just mass times acceleration. However, the force of drag, we need the drag coefficient and the cross-section area, which we don't have. That concludes my video. Thank you.